Okay, so before we dive into quotient of powers, let's review for a minute product of powers. My rule says that I can take exponents that have the same base. So if I had x to the 7th times x to the 5th, does everybody agree this expression has the same base? Yes. Okay? So my rule says that I can then add my exponents together. I have the same base, and now I can combine my exponents. We called this step 2 on Friday. All right, it's just simply saying, all right, I'm multiplying, same base, which means I can add my exponents, and my answer is x to the 12th power. 7 plus 5 is 12. We also learned a property called power of powers. Power of powers, let's take the same exponent values. Says that I can take one base, raise it to an exponent, and then raise it to another exponent. So the only reason I have parentheses here is so it doesn't look like 75. Would you guys agree that if the parentheses were gone, it would kind of look like 75? All right, so I have parentheses separating my power of powers. My rule says, with power of powers, that I will multiply my exponents together. So x to the 35th power would be my simplified answer. So the good thing on these problems, guys, is I leave my answer as exponents. All right, so sometimes you add the exponents, sometimes you multiply them. The third thing that we learned on Friday is something called the power of a product. So the power of a product says I'm going to have terms multiplied together inside parentheses. So do you guys agree this is 3 times A times B? Okay? So if I'm going to raise this product to the second power, that means I have to raise each term inside the parentheses to that power. I have to distribute the power. So we will write this in what we call expanded form. 3 squared times, not plus, times A squared times B squared. Now, is there any part of this expression that I can evaluate, that I know what it will be if I square it?
3 squared.
What is 3 squared?
9.
So now I'm going to bring it all back together with no dots and no spaces. 9a squared b squared. All right, so let's sum it up. Number 1, what property was that called? Product of powers. Number 2, what property was that called? Power of powers. Number 3, we used a rule called the power of a product, which just means that I have multiple terms being multiplied inside the parentheses, and I raise each term to a power. So today, we're going to add one more property to that. And we're also going to review these 3 properties that you've already learned. Today, we're going to add quotient of powers. So it really goes hand in hand with all those other properties. What does quotient mean? What does it mean, guys? Starts with a D.
Divide.
To divide. And that's what we see here, right? In all of these examples, we see division, right, Kaylee? We see division. So when I'm dividing powers with the same base, so remember, the base must be the same value in order to apply this property. What operation do I do with my exponents? I subtract them. So we're going to write step 2 in our notes today. You won't be required to write step 2 on your quiz and test, but it is really good mental math practice, all right, to train our minds on what operation to do when. So 2, would you agree, is my common base on the first problem? Would you guys agree? 2 is my common base. So you're going to write your common base, and your rule, the order is important on how you subtract. Your rule says that you will subtract the numerator minus the denominator value. It must be in that order. Okay? So we're bringing, here's what I need you guys to understand. I've had the question, well, where did my fraction go? Where did my fraction go? I'm subtracting my powers. And here's what this means. All right, you guys, if you can understand this, it's really going to help you with quotient of powers. When I subtract this 4 up into my numerator, here's what I'm doing. I'm bringing all of those powers of 4 up into the numerator. When I subtract the 4 in the numerator, what I'm doing is I'm bringing them all up into the top part of the fraction. So that's why nothing is left in the bottom. All right? So that minus 4 up top, that's actually represents 4 powers of 2. Okay? So what is 6 minus 4? 2. So 2 to the second power. Now, while this is very simple, usually with quotient of powers, you are told to leave your answer as a power. Which, sadly, on Big Ideas, if it says leave your answer as a power and you solve it, what do you think Big Ideas is going to do? Mark it wrong. Okay? So pay attention to the instructions. Pay attention to the instructions. All right. -7. Look at your -7 bases. Do I have the same base, top and bottom? So my rule says I can bring the 3 powers of -7. So that's what I'm doing when I subtract. I'm bringing them up into the numerator. So now I have my common base of -7 to the power of 9 minus 3. So what's left in the bottom, and I already wrote it, what's left in the bottom when I do that? Nothing, just my understood 1. Because I brought all 3 powers of -7 to the numerator. Now, I'm going to write my common base and just subtract. What's 9 minus 3? 6. -7 to the power of 6. Okay. Now let's look at our h's. What's my common base? H to the power of what? 7 minus 6. Now, what's left on the bottom? What's left on the bottom, guys? Just a 1, because I brought all the powers of 6 that were in the denominator. I brought them up into the numerator to subtract them. And what am I left with? H to the power of 1. So if it's to the power of 1, I can just leave it H because 1 is understood. So you can write it either way. All right, I want you guys to do the last one. Go ahead and work the last one. What's my common base? 4.2 to the power of what? Y'all tell me. To the power of 6 minus 5. Did you write it like this, guys? Did you write your step 2? So we keep it as a fraction. Here's why. I need you to understand that when you subtract your powers, you bring them up into the numerator. Is that making sense? All right, so that means nothing is left in the denominator. That will really help you on your lesson tomorrow. All right, especially tomorrow. Not so much today, but especially tomorrow. So what's 6 minus 5? 1. So do I technically need to write the 1? Nope. So you could just say 4.2. Just 4.2. All right, any questions on example 1? Anything? Okay, so now you're going to see multiple properties being brought into the same expression. For example, what do you see? What is this symbol up here in the numerator? That is multiplication. So here's what's really important, guys. You've got to keep your properties straight. When I'm multiplying powers with the same base, what do I do to the power? Do I add or subtract when I'm multiplying? I add them. So you have to keep your rules straight. So 3 to the power of 4 times 3 to the power of 2. When I add my exponents, what do I get? 3 to the power of 6. Now I have that over 3 to the power of 3. Okay? Now here's where I subtract them. And remember what happens when I subtract my powers. I am bringing everything into my numerator. So 3 to the power of 6 minus 3. You see what I did there? Quotient of powers. What is 6 minus 3?
2.
Okay, so 3 to the power of 3. And now they want us to continue to simplify. If my instructions don't say leave your answer as a power, I have to continue to simplify. All right, so let's just do it on this one for practice. What's 3 to the power of 3? 3 times 3 times 3, 27. Okay, the next one, we're not going to do that though because the number's really big. Remember, there's no calculator in this chapter, so I'm not going to ask you to evaluate really large exponents. Okay, so does anything need to be simplified in the numerator on this next problem? 2 to the 15th. Nothing needs to be simplified yet. I just need you to rewrite it. 2 to the power of 15. Okay? But what about my denominator? Lucas, is there anything I could simplify down here in my denominator? Now, he says I add them. Do you guys agree? Am I supposed to add my exponents? How do you know I'm supposed to add? Because you're multiplying powers with the same base. Okay? So that's why I have 2 to the power of 8. Are you guys catching on to when do you add them? When do you subtract them? Mm-hmm. All right. So now I am dividing. Isn't that what a fraction means? Division? So if I'm dividing powers with the same base, what should I do to my exponents now? I should subtract them. So I bring everything up into my numerator. 2 to the power of 15 minus 8. It's all up in my numerator now. I'm going to subtract them. What is 15 minus 8?
7.
2 to the power of 7. And we'll leave it. We'll leave it 2 to the power of 7. Okay, so let's do this last one. Is there any part of the fraction I need to simplify before I divide?
Yes.
Okay, I want you guys to go ahead and try to work this last problem before I tell you the answer. All right, let's see who can get it right. All right, so Julia, what did you simplify first? What did you do first?
I took the x to the 4th power and the x to the 7th power and added them together, and I got x to the 11th power over x to the 5th power.
All right, perfect. Okay, so is that where you guys got on your first step? Is that where you guys got? All right, and Reese, what did you do next?
So I put x to the 11th power minus 5 over 1.
Uh-huh.
And then subtracted them.
Okay, and what'd you get?
X to the 6th power.
X to the 6th power. All right, why did we put this over 1? All right, that's kind of an understood thing, right? That something's over 1, but why are we writing that, at least for now? Why are we practicing that?
Because the x's cancel out.
Okay, kind of. Are there any x's left in the denominator once I subtract them? No, they're gone. They're up in the numerator. So that's what I'm doing when I subtract them. I'm pulling them up into the numerator. They're not in the denominator anymore. All right, that's a really important concept for us to realize. Okay, example 3. What do you guys notice about example 3? Same base within an expression, but there's a lot going on, isn't there? There's fractions, there's multiplication, and here's where you guys can just solve it however you want. What if you wanted to simplify one fraction first? Could you do that pretty easily and then multiply them? Yes. What if you wanted to multiply first and then divide? Could you do that? Yeah, you could. So it really is going to depend on, how the expression looks. But I want you to notice this top left expression, right? So don't work them out yet. I know you guys are wanting to work them out. Notice this top left one and notice the bottom right one. I want you guys to realize they're actually the same setup. It's just the top left one, they split them, and the bottom right one, they kept them all together. All right? So, like I said, it's going to be up to you whether you look at the A's, simplify a fraction individually and then multiply, or if you want to multiply across and then divide. Are you guys understanding that? All right, do y'all want to try this before I tell you? You guys want a minute? Okay. All right, so we're going to do it both ways. Like I said, either way is going to be fine. The -4s, the way I look at it, I'm going to simplify the fraction first. So what would the first fraction be after I simplify it? What would it be? -4 to the what power? -4 to the power of what's 9 minus 5? I'm going to let you write your step right there to kind of save some work. What is 9 minus 5, guys? 4. So that's why I write it to the 4th power here. All right, so I have simplified my first fraction. Now let's simplify the second fraction. -4 to the power of 8 minus 2 now. What is 8 minus 2? To the 6th power. So now my fractions are gone, which means these are over 1 now, right? Because I subtracted everything into my numerators. Now I can multiply my powers, which means if I'm multiplying powers with the same base, what do I do to my exponents? Do I add them? Do I multiply them? What do I do? I add my exponents. What is 4 plus 6? -4 to the power of 10. Okay, so I simplified my fractions first, and then I added my powers. Okay, I want you guys to try the A's. All right, I want y'all to try this one before I tell you what the answer is. All right, what did you guys do first? Did y'all simplify the fraction first? That's probably what I would do too. So a to the power of 10 over a to the power of 6. Let's see, Sebastian, what did you simplify that to? A to the 4th power, and technically it's over 1 because all my powers of a are in the top now. All right, times, what did you get, or what would you get if you simplified your second fraction? What do you think, Macy?
A3.
Yep, a to the power of 3 over 1 now. All my powers of a are in the top. And Malia, what would be my answer? A to the power of 7. All right, thumbs up if you guys got that before I did. Did you guys get that answer? Now let's look at the expression with our p's. What do you guys notice that might be a little different, or maybe just one more step based compared to the last two? What do you guys notice? What about this up here in the numerator? You think you need to simplify that first? Yeah, you got to simplify that first. What do you notice about this p in your denominator of your second fraction? There's no exponent. What do you think is going to go there? An understood 1. You cannot forget that. You might want to go ahead and write it in so you don't forget it. So if I simplify my numerator, what is p to the 3rd times p to the 6th? P to the 9th power. P to the 9th power. Now, I'm going to caution you guys here. I'm not going to make you write this step. Okay? But the more you try to do in your head, the harder it is to remember and keep everything straight. Okay? So, do as much in your head or I'm sorry, do as much writing as you can and not as much mental math work. All right, so p to the power of 9 over 2 times p to the power of 4 over p to the power of 1. So now it's up to you. If you want to simplify the fractions by themselves and then multiply, or if you want to multiply and then divide. All right, I'm going to simplify each fraction. What is p to the power of 9 over p to the power of 2? What would that simplify to? All right, p to the power of 7. All right, and remember that's over 1 because all my powers of p are now on the top. All right, what about my second fraction? What does my second fraction simplify to? 4 minus 1 is 3. So p to the power of 3 over 1. What's my answer, guys? P to the power of 10. If you put it over 1, that's fine, but you don't have to. Remember, if something is written over 1, that's understood. So it's like a whole number type thing. All right, I want you guys to work out the last expression start to finish. See if you can solve it. All right, now because of how this one is written as one continuous fraction, to me, and again, you can do it either way. You could still simplify top and bottom here, but I'm going to go ahead and multiply the numerator, which means what do I do to my powers if I'm multiplying? I add them. So I get negative 5 to the power of 13 over negative 5 to the power of what? 7. Now I'm going to subtract my powers up into my numerator, and I get negative 5 to the power of 6.
Wait,
Did you guys?
add them? You added them?
Huh?
Did you add the exponents?
Yes, I added them first. So 5 plus 2 gave me the 7. And then I subtracted them. All right. Your friend simplifies this quotient. Is your friend correct? Now, we know oftentimes friends are really making some mistakes. I don't know. They could be correct this time.
No, they're not.
Okay?
Yeah.
All right. I want you guys to answer this. All right. Now, to explain your reasoning, you can either correct the mistake or you can just tell me in words. All right. And that goes for your big ideas homework as well. If you have a problem like this, you could tell me the correct answer or explain it in words. Here's what you can't say. My friend is incorrect. Or because they are wrong. I've seen some really, because I said so. I've seen some interesting answers here. I think it's because y'all think I don't read them, but I do. I do read them. Okay. What do you guys think? What do y'all think? Is your friend right?
No.
No, your friend is wrong. What did they do wrong? No. Subtract powers, not divide. I am dividing. So quotient of powers says you subtract them. So what is the correct answer?
6 to the power of 10.
6 to the power of 10 is the answer because 15 minus 5 is 10. So you can make it really short and sweet, but you have to give me an explanation for why they are wrong. Okay, here's your challenge question. Why do you think this is a challenge? This is the challenge question in your textbook.
30 on it because it's pi.
Nah, okay, it's bigger exponents, but it's a pi symbol. So it's like, ooh, it's a symbol now. So instead of a number, but do you think that it's any different? No. Is it all the same base? Yes. So you can still apply your properties.
Do you know all of pi? Do you know all the numbers of pi?
No, nobody knows all the numbers of pi. Not even the ancient philosophers dedicated years of their life to study pi.
How much do
All
you
right.
know?
2 digits. That's all I care about.
3.14.
Yeah. Pi to the power of 30.
That's all.
How do I simplify the bottom? What do I simplify it to? Pi to the power of what? 22. And then I subtract it. Pi, not pi 8, guys. Pi to the power of 8. We're going to use the correct vocabulary. Pi to the power of 8. All right, now let's take the rest of class to work on our big ideas homework for this lesson. Big ideas homework number 59.